Imagine looking up at the night sky and learning that somewhere in the darkness ahead, an invisible monster is waiting. Not a planet, not a star, not an asteroid, a black hole. And somehow Earth is heading straight toward it. At first, most people wouldn't panic. After all, black holes are often portrayed as giant cosmic vacuum cleaners, instantly swallowing everything around them. But the truth is far more fascinating and far more terrifying. Because if Earth were actually falling into a black hole, the end wouldn't happen in a single moment. It would happen slowly. The signs would appear one by one. The sky would change. The oceans would react. Gravity itself would begin behaving in ways that seem impossible. And eventually, humanity would face one of the most extreme environments the universe can create. So what would really happen if Earth fell into a black hole? How long could we survive? And would anyone ever make it to the event horizon alive? Let's find out. What is a black hole? Before we begin our journey, we need to understand what a black hole actually is. A black hole forms when a massive star dies. After exhausting its nuclear fuel, the star collapses under its own gravity. The collapse becomes so extreme that all of its mass is compressed into an incredibly small region. Gravity becomes so powerful that nothing, not even light, can escape. This creates what scientists call the event horizon. The event horizon is often described as the point of no return. Cross it, and escape becomes impossible. Beyond that boundary, every possible path leads inward, toward the center, toward the singularity, a place where our understanding of physics breaks down completely. Black holes are among the strangest objects in existence. Yet despite their terrifying reputation, many black holes are surprisingly quiet. If our sun were magically replaced by a black hole with the same mass, Earth would continue orbiting exactly as it does today. The difference would be the absence of sunlight, not an immediate gravitational catastrophe. This fact surprises many people. Black holes are dangerous because of their extreme gravity near them, not because they magically suck in everything from across the universe. But if Earth actually began falling toward one, everything would change. The first warning signs. Let's imagine a rogue black hole has entered our region of the galaxy. Perhaps it was ejected from another star system. Perhaps it has been wandering through interstellar space for billions of years. At first, humanity might not notice it. Black holes emit no light. They are effectively invisible. But their gravity reveals their presence. Astronomers would begin detecting strange motions among distant stars. Objects would move in unexpected ways. Gravitational measurements would stop making sense. Then the calculations would reveal the horrifying truth. Earth is on a collision course. News would spread rapidly. Governments would respond. Scientists would attempt to predict what comes next. But by then, the process would already be underway. The sky begins to change. As Earth moves closer, the night sky would start behaving strangely. The black hole's gravity would bend light itself. This phenomenon is called gravitational lensing. Stars behind the black hole would appear distorted. Some would seem stretched. Others would appear duplicated. The sky would begin looking like a giant cosmic funhouse mirror. Astronomers would witness some of the most spectacular visual effects ever observed. The closer Earth gets, the more dramatic these distortions become. Entire constellations would appear warped. The universe itself would seem to bend around an invisible object. For ordinary people, the night sky would become increasingly surreal, beautiful, and terrifying. Gravity takes control. As the distance shrinks, Earth's orbit would become unstable. The black hole's gravitational influence would begin overpowering the sun. Seasons could become chaotic. Earth's path through space would change. The moon's orbit might become distorted. Tidal forces would increase. At first, these changes might seem small. Then they would become impossible to ignore. Ocean tides would grow stronger. Weather systems could become increasingly unstable. Earth's entire gravitational environment would begin shifting. The planet would still exist. Humanity would still survive. But everyone would know something enormous was approaching. The point of no return. Eventually, Earth would reach a critical distance. At this point, Escape becomes impossible. No technology currently imagined could move an entire planet away from a black hole's pull. Human civilization would face an unavoidable reality. The journey inward has begun. The black hole would dominate the sky. Even though it emits no light, its presence would be unmistakable. Around it, distorted stars would create a glowing ring, a cosmic halo surrounding absolute darkness. Few sights in the universe could compare. Humanity would witness the most extraordinary object ever observed, and it would be the last thing our civilization ever sees. The tidal force problem. Now the real danger begins. Black holes do not destroy objects simply through gravity. The true threat comes from tidal forces. Gravity weakens with distance. This means the side of Earth closer to the black hole experiences a stronger pull than the far side. The difference creates stretching forces. For small objects, the effect is minor. For planets, it becomes catastrophic. Oceans would begin rising dramatically. The crust could crack. Earthquakes would become more common. Volcanic activity could increase. The entire planet would be subjected to stresses unlike anything in its history. As Earth approaches further, those stresses continue increasing. Eventually, the planet itself may begin to deform. Mountains collapse. Continents shift. The oceans surge across the globe. Civilization would not survive this stage. Spaghettification. Scientists have a wonderfully strange name for what happens next. Spaghettification. It sounds funny. It is not. As an object approaches a black hole, tidal forces stretch it vertically while compressing it horizontally. Imagine being pulled apart atom by atom. Your feet experience stronger gravity than your head. The difference becomes extreme. You are stretched into a long, thin stream of matter. Like spaghetti. For a human being, this process would be fatal long before reaching the event horizon of a smaller black hole. The body simply cannot survive such forces. But Earth is much larger. The planet itself would experience similar effects. The black hole would literally begin tearing the world apart, crossing the event horizon. Here is where things become truly strange. Suppose Earth somehow remains intact long enough to cross the event horizon of a supermassive black hole. From our perspective, crossing the horizon might not feel dramatic. There is no physical wall, no barrier, no cosmic explosion. You simply pass a point where escape becomes impossible. But for observers watching from far away, something bizarre happens. Time appears to slow down. As Earth approaches the event horizon, it seems to move more and more slowly. Eventually, it appears frozen at the edge. Its light becomes increasingly redshifted, dimmer, redder, until it fades from view entirely. To distant observers, Earth never seems to fully cross the horizon. Yet from Earth's perspective, the crossing happens normally. This is one of the strangest consequences of Einstein's theory of relativity. Inside a black hole. What happens after crossing the event horizon? The honest answer is simple. We don't know. This is where modern physics reaches its limits. General relativity predicts a singularity, a point of infinite density. Quantum mechanics suggests reality may behave differently. Scientists have proposed many possibilities. Some theories suggest information is preserved. Others suggest connections to entirely different regions of spacetime. Some even speculate about wormholes. But no one knows for certain. The interior of a black hole remains one of the greatest mysteries in science. Everything beyond the event horizon is hidden from the rest of the universe. Forever. Could humanity survive? Could humanity somehow escape? The answer depends entirely on timing. If scientists discovered the threat centuries in advance, perhaps future civilizations could build enormous space habitats. Perhaps humanity could spread across multiple star systems. Perhaps Earth would be abandoned long before the final encounter. But if the event occurred suddenly, no realistic technology exists today capable of saving an entire planet. The best hope would be evacuation, not of Earth, but of humanity itself. The bigger question. As frightening as this scenario sounds, there is good news. No known black hole threatens Earth. None are on a collision course. Our solar system is remarkably stable. The nearest known black holes are far away, far beyond any realistic danger. Yet black holes continue teaching us important lessons. They reveal the limits of our understanding. They challenge our theories. And they force us to confront questions about space, time, gravity, and reality itself. In many ways, black holes are not simply cosmic monsters. They are laboratories, natural experiments created by the universe. And they may hold the key to some of the deepest mysteries in existence. Conclusion: if Earth fell into a black hole, the end would not arrive as it does in movies. There would be no giant explosion, no instant destruction. Instead, the process would unfold over time. The sky would change. Gravity would intensify. The oceans would rise. The planet would begin tearing itself apart. And eventually, Earth would disappear beyond the event horizon of one of the most mysterious objects in the universe. Fortunately, this scenario remains science fiction for now. But the fact that we can even ask such questions reveals something extraordinary. Humanity lives in a universe filled with wonders beyond imagination. And among those wonders, few are more fascinating than black holes. Invisible, powerful, and still waiting to reveal their secrets.